Precalculus third 9 weeks test. This is a review of the test we had a little while ago in pre-calculus class. 22 problems, most of which consist of law of cosines, law of sines, and basic vector problem. 1. For triangle ABC shown below, what is the length of the unknown side B to the nearest 10th of centimeter? We don't see any right angles here, but we have what we call a known side opposite a known angle. So this known side opposite a known angle represents a ratio that we can use called the law of sines. And that is, if we have a known side, in this case 19, over a known angle, which is going to be 70 degrees, that ratio, 19 over sine of 70 degrees, is equal to any other side opposite the side of an angle. So we want to know side B, and side B over sine 37 degrees is that second ratio. And if we cross multiply, B is equal to 19 sine 37 degrees over sine 70 degrees. And so we can go to our calculator. And as I go to the calculator, the first thing I notice is that am I in degrees here? No, I'm in radians mode. So I'm going to hit the mode button here and make this a degree. So let's go ahead and put (19) sine 37 degrees over sine 70 degrees. And then last thing I do is check to make sure everything's right. Oops, I put 17. That's why we check. Okay. 12.2 round to the 10th. Equal to 70. Yeah, it's going to be closest to answer choice B. Next, 2. For information given below, was measured angle P to the nearest 10th degree. Well, similar to problem 1 with an one side opposite an angle. So that means that the sine of 110 degrees, its relation to 22, its side opposite, is equal to the sine angle P. There's angle P down here. Over 8. And so cross multiplying sine P is equal to 8 sine 110 degrees over 22. And P is going to be equal to the inverse sine of 8 sine 110 degrees over 22. And so let's write my answer down below. So P, again, make sure our calculator is in degrees. Second, sine, which gives me inverse sine. We have 8 sine 110 degrees over 22. And I check to make sure everything's right here. Press 19.98 degrees. Which is closest to answer choice A, 20 degrees. It's the nearest tenth, it would be 20.0 degrees. Okay, next. Which of the four triangles shown has the unknown side A that can be solved using law of sines? Well, in problems 1 and 2, we verified that for law of sines, you need a known side opposite a known angle. And in triangle A, we do not have that, nor do you have it in triangle B, nor do you have that in triangle C. But it is in triangle B that we have a known side, 33, opposite a known angle, 9 degrees. So B is our correct answer to problem 3. Next, 4. Which of the four triangles shown below is not an immediate law of cosines application? Well, what you're looking for law of cosines, you're kind of looking for like a Pythagorean Heron problem where you don't have a hypotenuse, except you don't need to have a 90-degree angle. But you have two sides here for answer choice A, and your unknown side is opposite the known angle here. So A cannot be correct, nor can B. One is not a law of cosines application here. And answer choice D, we have a known side opposite a known angle. That's going to be it. And I don't see a law of cosines application. And when you have a side, that is a law of cosines application on one side. So in this case, C is going to be our correct answer. Number 4. John Bob hike in different directions according to Long shown. Bob hiked 5 miles and John hiked 4 miles, separated by an angle of 9 degrees. So this one here is going to be like if you have all this angle C and this distance apart side C, and these other angles we call them B and A respectively. So this 5 miles would be side A, this 4 miles would be side B. So what we have is C squared equals A squared plus B squared, which is Pythagorean theorem. But our angle opposite our unknown side not being 90 degrees, we have to make our adjustment for law of cosines. Minus 2AB cosine big angle C. And what we can do is take the square root of both sides. So C is going to be equal to, I'm just going to plug in the numbers here. I get 5 squared minus 4 squared minus 2 5 times 4 cosine 100 degrees. Now going to calculate. Make sure that you're still in degrees. So 5 squared plus 4 squared minus 2 5 times cosine 100 degrees. I'm just kind of looking at this. Looks like everything is in place. That's going to be 6.92 miles. which to the nearest tenth of a mile is going to be 6.9. That's 4 feet. Next, be a ship moving toward the arrival point F. There's our ship at point F. See between point E and lighthouse point B, an angle measuring 67 degrees. So this 67-degree angle opening up before the ship between the lighthouse and the island at point E. If you look out lighthouse, measures an angle of 36 degrees between the ship and the island at point E. 20 miles was the distance D between the ship and the island at 10 miles. Here we have a known angle opposite the known side. So that's going to be what we call a governing ratio. So we're going to have 20 over the sine of that angle, 67 degrees, is equal to our unknown side B over the sine of 36 degrees. So B is going to be equal to 20 sine 36 degrees over sine 37 degrees, sine 67 degrees. So B, let's work it out. That's 20 sine 36 degrees over sine 7 degrees. And for that, we get 12.77 miles. Which, to the nearest tenth of a mile, is going to be, let's choice C, 12.8 miles. So the coordinates of A are 2, 3, and the coordinates of point B are 7, -6. What is the vector A, B, and 4? For this, we taught in class the concept of head minus tail to determine the vector. And even before doing that, if you go ahead and graph on the coordinate plane what the thing looks like, if we put 2, 3, point A, so 2, 1, 2, 3. So here is 2, 3. And the coordinates of point B are 7, -6. So 1, 2, 3, 4, 5, 6, 7. And negative 1, 2, 3, 4, 5, 6. We have 7, -6. What are we going to have? We're going to have this vector right here. And what is that going to be? And that's the start. But with head minus tail, so we have B minus A. What we're going to have is 7, -6 up here. And we have 2, 3. And then so it'll be in the component form, it's going to be 7 minus 2, or 5, and -6 minus 3, or -1. And you can kind of see that, I hope, because if you kind of measure this thing out here, you're going to go 5 to the right, 1, 2, 3, 4, 5 to get to here, and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5, comma, -1. That's your choice A. Next, H vector B is 2, comma 5. Vector W is 4, comma -3. If vector P is 2B minus 2W, what is vector P in component form? Well, first of all, I'm going to find 2B. It's going to be 2 times this thing right here, which is 2, comma 5. So that's going to be 2 times 2 is 4, and 2 times 5 is 10. So that's 2B. And 2W is equal to 2 times -4, -3. So that's going to be 2 times -4 is -8, and 2 times -3 is -6. So now if we subtract these, we're going to get vector P, which is one subtracted from the other. So we have 4 minus -8. 4 minus -8 is 12. And then we have 10 minus -6. It's going to be 16. That's choice B. Next, 9. What are two characteristics of a vector? Magnitude and direction. Not up and down, not force and distance, not speed and work, magnitude and direction. I have a little video clip from Despicable Me. 10. If you know each of 3 sides of a triangle, what is the first thing you need to do to start solving for the angles? Well, what we are looking at is the same thing we were exposed to in this one right here. Which one is not? This one right here is the one we're talking about. We have 3 known sides. So we will be able to immediately use the law of cosines. We're going to go into another problem like this one. 11. Rodney walks to the library after school every day. When Rodney leaves school, he walks 12 miles due west. So if we draw a little XY coordinate plane, and Rodney starts right here at the origin, and Rodney goes west, and the west is to the left, so he goes 12 miles here, and then due north, which goes up here, 9 miles. Now we're interested in this distance here, question mark, and the angle of elevation here. And to find the distance, our distance formula, distance can be to square root of 12 squared plus 9 squared. And we work that out, we're going to get 15. That is our direct distance, our Rodney's direct distance. Therefore, C and D are incorrect answers. Now for the magnitude here, our tangent, our theta, is equal to our opposite, which is 9, over our case of 12. So theta itself is going to be equal to inverse tangent of 9/12. And look at that calculator. We are in degrees, 9/12, 0.75, going to be 36.87 degrees. And which is closest to that? That's going to be that's your choice. Okay, next. On 12, we have a vector u, vector v, vector w. What is 3v minus 4v plus 2w? In this case, I recognize that all of our first coordinates here are different numbers. And what that means for us, it can really lighten our load because it means that we don't have to analyze everything. So if we want 3u is equal to 3 times 8 comma 12 comma -3. Okay. And that's going to be 24, right? 2 times 8 is 24. Minus 4v is 4 times, and v is -4, comma 7, comma 14. And that's going to be equal to 4 times -4 is -16. And then we have 2w, 2 times 2, comma -5, comma 6 equals 4. So we take 24 minus -16, which is the same as adding 16. 24 plus 16, that's 40. Plus 4 is going to be 44. And we can check all these other coordinates to see if they're right too. But B, in this case, is our correct answer. Okay. Next problem, 13. What is the reference angle for an angle that measures 315 degrees? So reference angles have to be positive, and they have to be between 0 and 90 degrees. So if you have this standard position angle about 315 degrees, that's where our terminal side is over here. So that will be theta, 315 degrees. Our reference angle alpha is going to be the entirety of the circle minus 315 degrees, which equals 45 degrees. So that is our correct answer. Okay. Next, point P is rotated 210 degrees counterclockwise. We want a circle diameter of 20 meters. Well, diameter is 20 meters. That means our radius is going to be half that, or 10 meters. What are the coordinates? The song we'll be singing. And y. In this case, r is 10 meters. So x is going to be equal to 10 times cosine theta. Well, over here, cosine is going to be negative square root of 3 over 2, which is going to be equal to negative 5 square root of 3. And for y is going to be equal to 10 sine theta, and sine of 300 is going to be negative. And that's going to simplify to -5. So we want the coordinate pair, -5 square root, comma, -5. That's the first thing. 15 2/4 upon object is shown was 19 fourths. Well, in this case, in the vector, we have a combination of two vectors, and so we can write our x-coordinate of that component one vector as 15 cosine 20 degrees plus this downward vector here, which would be 12 cosine negative 27 degrees. So that is going to be our x-coordinate for our component form of the vector. And then this one over here is going to be y, 15 sine 20 degrees plus 12 sine negative 27 degrees. Let's see. So what we have here is a calculator. So we have 15 cosine 20 degrees plus 12 cosine negative 27 degrees. And that's going to be our x component of vector, and the y component is going to be this is right here, 15 sine 20 degrees plus 12 sine 27 degrees. We get this negative 0.317. So to find a magnitude, we take component form. What happens is our y value is quite negligible, so it's going to be very close to what this x component is. Just be sure we get a second. Right up here, highlight it, press enter, and we can just square that plus parentheses. And the last thing calculated is the second insert. Square that. So we get 24.79. That's a magnitude. Let me just get that over. Closest 24.8. So that's that. Next, if cosine theta equals 5/13 and sine theta is less than 0, what's cotangent theta? What we're looking at is there are different ways to do that. The way I like to do this is if you remember the whole thing, all students take calculus, remember that? And so what this, we're looking for a place where cosine is positive, but sine is negative. We see it down here in quadrant 4. And cosine theta is going to be adjacent over hypotenuse. So if we go over here 5 units, 5, so adjacent is equal to 5, and the hypotenuse is going to be 13. So this hypotenuse down here is 13. Okay, what is cotangent. Well, cotangent is going to be, we don't know what this side over here is, but cotangent is going to be adjacent over opposite. So already we have adjacent positive and opposite negative. So we know we have to have a negative answer. C and D are not correct. To find this side here, on the side, it's going to be square root of 13 squared minus 5 squared, which is going to be square root of 144, which is equal to 12. So opposite side is 12, and adjacent over opposite is going to be negative 5 over 12. That's a choice B. Next, 17. What is the exact value of 10 negative 19, 5, or 6? Now here, one way to do this is to convert this to, or you can leave it in radians, package over degrees, convert to degrees, and find which one is the equivalent answer. I'm going to do this without the calculator. What happens is, when we talk about sixths, 2 pi is equal to 12 pi over 6. So if we go ahead and take our tangent of negative 19 pi over 6 is going to equal to tangent of negative 19 pi over 6 plus 12 pi over 6. And negative 19 plus 12 is going to be negative 7 pi over 6. And then we can add again if we want to. Tangent of negative 7 pi is going to be equal to tangent of negative 7 pi over 6 plus 12 pi over 6, which is going to be a tangent of 5 pi over 6. That's going to be quadrant 2, so we're going to have a negative for answer. And we're going to have square root of 3 over 3 is what it amounts to. That's going to be like tangent 150 degrees. And what we get is square root of fingers over, so it can be a little complicated, but our correct answer is going to be negative square root over 3. So what we have is going to be 1 over negative 1 over square root of 3, and rationalize that becomes negative square root of 3 over 3. And if you look at that at 150 degrees, you should see out here that the height here, the opposite, is going to be less than the adjacent, so less than 1, but negative in this case because we're only quadrant 2. We're trying to show one of these areas. Well, here, Maybe using the class called Heron's formula. And Heron's formula is area. Let me just write that. Area equals the square root of S, the semi-perimeter, S minus side A, times S minus side B, times S minus side C. And so, in this case, we don't have this side over here. What do we have to do to find it? Well, we can use law of cosines to find it. So we have side P, which can be equal to square root of 11 squared plus 8 squared minus 2 times 11 times 8 times cosine 18 degrees. So let's look at that. 11 squared plus 8 squared minus 2 times 11 times 8 times cosine 18 degrees. So that's our side there. Now to get the semi-perimeter, we need to add the three sides together. So if we go ahead and make this, I'll just put plus there, 8 plus 11, and we divide this by 2, we have our semi-perimeter. We're just left in calculator. And to find what our area is, now we can go to second square root, and we'll put our last answer calculate, second ANS, that's S times minus, and we come up here and get our side that we calculated. There it is highlighted, press that, close parentheses, ANS minus 11, close parentheses, open parentheses, ANS minus 8, close parentheses. And so we get 13.6. Well, that's not true. There should be about 4.2. And then area is going to be approximately 13.6 using this formula. That's your choice B. Okay. 19 vector being component form is 4, 5. What is 19 vector b moves 10? Well, magnitude is going to be equal to this formula here, which is y2 minus y1 squared plus x2 minus x1 squared. And when we're given the vector and component form, we can just, in the place, put the numbers. -4 and 5. We're going to get square root of 16 plus 25 equals square root of 41. And that's approximately equal to 2 years 10, I think it is, right? 2 years 10.4. put 6.4. 6 will go here. Point. Point triangle side measures the sides. Measure should be sides. That's the word. Have what area around the nearest tenth. Well, again, it's going to be our nearest formula. It's going to be F, it's going to be F, that's my B, that's my C. So we have S, it's 10, it's 14, it's 9, divided by 2, equals 20, will be 33, divided by 2, equals 11.5. So our area will be square root of 11.5 and 11.5 11.5 minus 14 minus 11.5 minus 9. And this is 9.9 minus 11.5 minus 14. That's not right. That, my friend, is going to be a problem for us. It's 16.5. That's why it helps to look at this over. So all of this here is 16.5, 16.5. Sometimes it just pays to put it in. Okay, let's go back to calculator. Sorry about that. What gave it away here? What happened when I subtracted 14, I realized I'd get a negative number. Okay, and then 16.5 minus 9. Oops. The nearest 10. So 44.8 is what I go here. And you might have a program put in a formula in the calculator, so that would have helped you to make avoid potential mistake that I was cause us making. Okay, number 21. Final length of side P is nearest 10th of an inch. Mark your answer and grid provided. Here we have a known side, opposite known angle. So that's going to be our governing ratio, which will be 9 over sine of 133 degrees. is going to be equal to side P over the sine of 13 degrees. So P is going to be 9 sine 13 degrees over sine 33 degrees. So, my calculate. 9 sine 13 degrees over sine 33 degrees. We get 2.768. And we want to the nearest tenth range, which is going to be approximately 2.8. The closest tensor is 2.8. I know a lot of people got different answers. This one should be that. Okay. And next to our last problem in the test. Mark the measure of angle A. Well, here we have the law of cosines. We want the measure of angle A. So that's going to be, the formula is going to be 10 squared equals 17 squared plus 11 squared minus 2 times 17 minus 11 cosine of angle A, if you don't know yet. Once you go ahead and make all the subtractions and so forth, it's supposed to be 17, come up with 12. What we're going to get is angle A is going to be equal to inverse cosine of 10 squared minus 17 squared minus 11 squared over negative 2 times 17 times 11. And so we will get what A is approximately equal to. And go to the calculator and go to inverse cosine of 10 squared minus 17 squared minus 11 squared over negative 2 and 17 times 11. I don't know in my 6th period class if we got this one. Anyway, 34.0 degrees to the nearest degree is what it's asking. So 34 degrees to the nearest degree. I saw some people get 108. I think if you get 108, I think you probably use the wrong, solve for the wrong angle. That might be the case for, I'm not sure, angle B. Anyway, that is our correct answer, and that's it. In our class, I think Noah missed only one, and there are several others who did quite well also. I hope this can help you. Good luck, and thanks for viewing.